Hey everybody, this is Beck. In this video, I'm going to show you how to write an Ethereum smart contract using the Solidity Programming Language, Part 2. The first thing I want to do in this video is actually update the smart contract code that we wrote in the last video to support the newest version of the Solidity Programming Language, which is 0.5.1, I believe. Now you can actually see the compiler version over here has changed. And in the last video, we wrote this smart contract, and there's some compilation errors you can see over here on the right. So you have to update this code to support the newest version of the Solidity programming language. And I wanted to go ahead and do this. I wanted to go ahead and support the new version of Solidity so that when I make more videos in this series, they'll be up to date and you'll have the newest version. So let's see what we need to do. We can read the error. It says basically the data location must be memory. And that's actually the error in both cases. So all we need to do in this case is actually just return memory here. And then whenever we're passing in the value a string, we actually need to put memory here as well. All right. Actually, that needs to be before value, my fault. And now theirs go away. So we will select the newest compiler version. We'll say, let's do the latest complete version, 0.5.1. Start to compile. And hopefully the compilation will work. Yep, it worked. So let's go to run, and we'll deploy. And see if it worked. So get the value. Yep, it worked. Awesome. Now let's move on to the next part of this tutorial where we'll actually cover the content for this video, which is going to be, the basic data types and data structures in Solidity and how you can use them when you're developing your own smart contracts. So I will change some values in here to kind of show you what that is. The first thing I want to talk about are, the different ways we can work with these state variables, right? So the first thing I want to mention is, we have this string value here that we had declared, and we set it here inside this set function, and we had this getter function where we read that value, right? So Solidity has a shortcut where I don't even need this function. I can actually just read this string value for free. I can actually get this function for free, take this out, and just declare this public. And that's declaring the visibility of the state variable here. Actually, public goes before. So I'll save that, and I'll compile it, and I'll run it. And we'll see that a getter function called value, the same name as the state variable, was exposed to us by the smart contract, and we can see it works just the same way as that other function did. So that's a really nice way to save yourself from writing extra code. You can just get that function for free exposed to the public interface of the smart contract whenever you store your state variables that way. Okay, so the next thing I want to talk about inside of here is actually, we could set this as a default value. We don't necessarily have to put, my value here in the constructor. We could just say this, all right? We can take this away. Oops. Take this away, and we will run that again. Let's just clear this out. Deploy, all right? And we can, actually, sorry, I already compiled it first. Deploy it again. Get the value, and we can see it's my value. We can also set this value as a constant if we don't want it to change. If we don't want to allow a user to set this value, if we want it to stay the same, we can just say constant. All right, that actually declares a constant. We had to remove this function. We can't update this value at all. Solidity won't let us do that. So we could just do that. I'll deploy this again, and we can still see our value is here as my value. So yeah, that's how you would add a constant to your state variables or make your state variables a constant. Now let's look at some other data types in Solidity. Let's just change this name. We'll call this like string value. All right, let's just deploy that. We can see this instance here again. String value, all right, it's my value. Now let's explore some other data types. We can say Boolean type, we'll say bool, public, is equal to, I'm going to remove this constant for now. My bool equals true, all right? So this just accepts true or false, and we can deploy that. See this, So my bool, right? It's true. String value is my value. Say, or my string. Just save that, just for fun. And we can also see that, we support data types like integers. So integers can be signed or unsigned. So what does that mean? Well, we can do a default int, which would be public my int equal to 1, right? So we can deploy this and see. Let's actually just clear this out. Sorry, deploy this and see my int equal to 1. So the difference between an int and a uint, or an unsigned integer, is that an integer can be signed and an integer can be signed and a uint can be unsigned. So what does that mean? Well, basically an int can be negative. So I can do -1, all right, and deploy that. That's a signed integer. It has a sign in front of it. It can be positive or negative, and a uint can't. So we'll deploy that, clear these out, and see my uint, all right, and my int, all right. Yeah, so -1 can work for an int, and they can't do negatives on unsigned integers. You can also specify the amount of bytes or bits in an integer. So we can say uint 8, public equals my uint 8, equals like, all right, oops, let's do a small number. And we can see my uint 8, all right. And so if we do uint here, it defaults to 256, I believe. Uint 256, public, my uint, okay. So that gives you a basic overview of all those basic data types. I don't want to bore you with all the pedantic details of this kind of stuff, but this is helpful to know, I feel like. And the next thing I want to show you is an enum. So what is an enum and how do you use it? Well, an enum is basically an enumerated list that's going to allow us to keep track of, set list of things in our contract. So I'll show you what that means. So basically, I can declare an enum like this. I'll say enum state, and I'll give it some options here. I'll say waiting, ready, active, all right? And this is going to allow us to keep a list of these 3 states inside a smart contract. I'll be able to reference this to see what the current state is, and it'll give us some options whenever we're updating the state and like checking against this. So I'll show you an example. We'll actually store this like this. We'll declare state, public, state, with this, all right? So basically, this is going to give us a public, we're going to be able to access this publicly with that getter. So inside of here, I'll do a constructor. I'll say constructor, I'll say public, I'll say state equals state active. All right, so I'll go ahead and set the default state to active, right? So actually, let's do this. Let's do waiting. And then I'll create a function to activate it. And I'll say activate. And I'll say public state equals state dot active. So we can actually choose, we can choose this value out of this enum list and update the state to that value, all right? So whenever we call this function, it'll change the state to the active state. And let's get a function that checks to see if the state is active. We'll say function is active. And we'll say public view returns bool. All right, and we'll say return state equal to state.active. So that's what we'll do inside of here. We'll just check to see if the state currently is active. All right, so let's see if we have any errors. Looks good. I will compile this. All right, we'll do run deploy. All right, let's check the state. So is the state active? All right, no, it's false. So that's true. It's not active. It's in waiting. So let's actually check the state. So the state is 0. So 0 corresponds to the first item in this list, 0, which is waiting. And I'll click activate. All right. So I actually call the activate function, which updates the state to active. Let's see if it's active. Yep, it's true. And let's check the state. So now the state is 2, which is 0, 1, 2. All right, so that's an idea of how you use enums. Let's look at the next concept that I want to show you. The next concept I want to show you is, let's do structs. So structs are basically a way for you to define your own data structures inside Solidity. We'll do that like this. We'll say, we'll create a struct right here. We'll call it person. So struct person, and we'll give it some, look at some characteristics. We'll say string first name and string last name. Okay. So basically what's going on here is this allows us to basically model, our own sort of arbitrary data. I'm just going to model a person with this struct that's going to have a few attributes. It's going to have a first name attribute that's going to be a string and a last name attribute that's also going to be a string. And we can put these structs inside of like arrays and mappings and things like that. I'll show you that here in a minute inside this video. But for now, just know that we declare that we've defined this new data type person inside the smart contract with a struct that's going to have a first name and a last name. Okay, so let's actually create a function that allows us to instantiate a new person, create a new one, and we'll actually keep track of a bunch of these person structs inside of a people array. All right, so let's do that like this. Let's say let's keep track of a bunch of different persons so that we can create new ones. We'll say person, so it'll be an array, public, people. All right, so let's see what's happening here. People is a state variable here, and it's public, so we can read it outside the smart contract. And it's an array here of these data type person, right? So we declare the data type for just person, which we defined here as struct. It's an array that contains these person structs. It's public, and it's stored with the people state variable. So we can add people to this array, or person structs to this array like this. So create a function. Say function add person. The string. This is a Solidity 5 update. Memory, or 0.5, sorry. A first name, and then we'll say string memory last name. We'll say public, and we'll do this inside here. Say people. Push. So push is a function we can call in arrays to add a new item at the to be array, and we'll push a new instance of this person struct. So we can create a new instance like this. We just call person, right? And we pass in these attributes. So we say first name. Name and last name. All right. And what we can do here is, we've added it. Let's go ahead and do it. So let's just compile this and run it. I'll deploy this. All right. So let's see what happens. So people, let's go ahead and add the person. Add person. Let's do the first name. So first name will be DAP, last name will be university. We'll add person. Okay, awesome. So that didn't give us any errors. Now, how do we read this person out of here? That's a good question. So we add this person to an array, but this function, whatever we call this person, this people function, it's not going to return the entire array of people. That's because this is we don't know the size of this array is in Solidity, and we have an array of unknown size. It's not going to return the entire array. So basically we need to reference the person by ID. So whenever you get this function, it expects an argument, which is going to be the index of the person inside this array. So for example, we know we added one person in there, so we will add people, and we'll say 0. All right, there you go. DAP university. So what happens if we reference, a person that doesn't exist? Say person, like 1 people. It's going to give us an error. It's an invalid opcode error. That's because there's no one in there at position 1. So how do we fix that problem? Let's keep track of that like this. So basically, we would keep an internal count of the people. We'd say something like this: uint 256 people count. Okay, and that's going to basically have just a counter cache that will increment every time a person's added. So we can say something like people count plus equals 1. All right, and we do that after, I guess. All right, save that, deploy. And now we can, actually, let's make this public. Oops, sorry, as before. Let's try it again. So now we can add the person, DAP University. Add person. And we can see people count is 1. So we would do 1 minus that, people. All right, DAP University. We do 1 minus that because it's a 0-based index, which means the first item, is at index 0, and the second one's at index 1, etc., etc. The next thing I want to show you is how to do a similar concept here, but model it a little differently. So instead of using an array, we're actually going to use a mapping. So what is a mapping? A mapping is basically like an associative array. So instead of having, just an array, and we know that each index of the item in the array, we can actually associate it to a value. So let's look at like a hash table or a hash map or a hash, and other programming languages that you might be familiar with, where basically you can reference things by, a key value. It's key value pair. So instead of having people like this, instead of it being an array, I'm going to change it down here. I'm going to say this is going to be mapping uint person. Okay. So uint is going to be the key, and the person is going to be a value. So this mapping is, like I said, an associative array that's going to take a key value pair. The key is going to be an unsigned integer. We'll treat this like an ID. So it'd be kind of like our database lookup, where we have an ID and then a record. So this is going to return kind of like a record, like a person record, or a person struct in this case. And it'll be public, and it'll be people. And it is kind of a fair comparison to compare this to a database, because, blockchain kind of is a big database, and these structs are, getting stored in storage on the blockchain with this mapping. All right, so person, string, first name, last name, and we'll do add person. So when you modify this function, we'll still take the first name, we'll still take the last name, but we're going to put this in the mapping instead of the array. So I don't know this people count back up here. We're going to want to keep track of this, just like we did earlier, so we know how many people are in this mapping. But we'll add it to the mapping like this. We'll say people count. So it'll be your ID. So if it starts at 0, which it will, do this. All right, people count plus equals 1. That'll be the new ID of the person that's going to go in here. So this will be person number 1 the first time we add this. We'll say this is going to be a new person. And we'll give this an ID. We'll say uint ID, okay, people count, and then we'll say first name, and then last name. All right, and we'll take this out. All right, let's see if that worked. Clear this out, deploy the contract. So we'll do first name is DAP University. Add person. Okay, so see people count is 1 now, and we'll go to people. This time it won't be based on the array index, it'll actually be on the ID, so we can actually reference person 1. All right, we'll do people 1. There we go, DAP University. So let me explain a couple more things about structs while we're here. We need to keep track of this people count because there's no way to know the size of this mapping in Solidity. Basically, any key that doesn't have a value set for it's going to turn a default value, which is going to be like an empty struct here. So if I do like, person, 10 or like 9999 people, it's just going to return default values. So what are the default values for the struct person? The ID for a uint is going to be 0, and then these blank strings for first name and last name. So that's why we need to have a person count. So if you were going to use this like as a data storage, and you wanted to like show all the people or all the persons in your people mapping in your app or something like that, reading from the smart contract, you want to know how many are actually in there, and you want to do that with a counter cache. So that way, if you wanted to basically like the same thing with those variable size arrays, like if you wanted to get all the items, you need to first make a call to find out how many there are. That's what you use the counter cache for. And then you basically create a loop to read out each one by one. So yeah, it can be kind of a pain, but that's sort of just the state of things and what you have to do.